have it. I just can't print it out.
Yes.
Okay, well, you don't
Yeah.
have to print it out if you don't want to, but it was for people who wanted to follow along. Hopefully, it should look very familiar.
Yeah.
It was not a very enthusiastic yeah.
She doesn't want to remember it.
That too.
Okay. Okay. So, number one. Pretty sure at some point everybody figured out how to show that it was isosceles. Does anybody need me to show how that is isosceles?
I mean, it'd be nice. Because I don't remember any of it. It's been so long.
Okay, Deborah, how do you show a triangle's isosceles?
I don't know.
What does it mean to be an isosceles triangle?
The
Two
two of the
sides are
sides are the
congruent.
same. Oh, you have to figure out which sides are the same.
Right, you should find the distance between all of them and show that they are equal. Two of them will be equal, not three. So some of the you guys, I did let slide a little bit. You can't just show two of them. You have to show two of them are the same, and the third one is not the same. If you don't show that third one out, you only show the two. It could be an equilateral triangle, not an isosceles triangle. So you have to be careful on that.
Well, is that one of those things where an isosceles triangle is an equilateral triangle, but an equilateral triangle is an isosceles triangle, but an isosceles triangle is not an equilateral?
No. Isosceles has two congruent sides and a third non-congruent side.
Well,
by definition.
okay.
So equilateral triangles are not isosceles. So it'd be nice if it worked out that way, but no. So if you have all three of them congruent, it's not like square rectangle thing. You do have to show that the third one is not the same as the other two. Okay. As for finding the area, some of you struggled a little bit with finding the area for some reason, because I don't think you really drew out what the picture was. So is it -2, 8, 320? This marker's dying.
Did you just use like distance formula?
30.
Yes.
Not for the area.
For area, but for the isosceles part.
Yes. You can use either Pythagorean theorem, distance formula, any way you wanted to get that two of them were the same in 11.
Okay, because, yeah.
And then 11. And then 2. So if you would have graphed your triangle, which would have been a very good idea, at least to get a sketched idea of what it looks like, there is your triangle. You should have realized that the bottom part was flat, giving you a great base, because that base is a very easy way to figure out what that distance is. And then just figure out the height. Well, the height is very easy. You just draw it from here down. We know that forms a right angle. So your height would have been 12, and your base is what, 13? So the area is just 1/2 12 times 13. So especially anytime you're given a picture with coordinates, I highly suggest you drawing out coordinates. They'll be very helpful. So that one, for the most part, was pretty well gotten, especially the first part. I don't remember off the top of my head if anybody didn't do the first part. Second part, some of you guys struggled with a lot more than you had to, because I don't think you thought about what the coordinates actually made and how it worked. Okay. Number 2 is where we did start running into trouble. So what is it? X to the 1/3. So x to the 1/3 minus 2. X. What's it equal to on the right hand side, somebody? Anybody? Nobody?
1.
Thank you. Okay, so they let you know that making the u substitution of x equals 1/3 would probably be a good idea. I think they said y, didn't they? Yeah, I guess they said y. So u substitution, you can use any letter you want. They used y in this case. They let you know that, hey, in case you don't know what to do to solve this, that's a pretty good hint. Couple of options you have at that point. The first one being this can't be substituted out the way it is, so what I would have suggested doing is changing it to 2 over x to the 1/3. And then you can make your substitutions. This is probably what I would say is the easiest way. So you get y minus 2 over y equals 1. Well, now, pretty easy equation. The only problem, hard part with that is that you have a y in the denominator. So how do I get the y out of the denominator?
Like 2y to the negative first power.
Well, that's still in the denominator. It's just rearranging it.
Oh.
But I can't have it in the
multiply by
denominator.
y.
There you go. I don't know how many times I've said this. If you have a fraction and you want to get rid of a fraction, and it's usually good ideas to get rid of fractions because it complicates things, you multiply through by the denominator. So I don't care what the denominator is. In this case, it's a y. It's fine. But I'm going to multiply everything by y. Give me y squared minus 2 equals y. And how do I solve y squared minus 2 equals y?
Move the y over.
So move the y over. You're solving a quadratic equation, so something was squared. You have one of two options. In this case, the only real option is to move it over, get it equal to 0, and then do what?
Factor.
Factor. So you get y minus 2 and y plus 1 equals 0. So y equals 2 and y equals negative 1. We do have, just like with our u sub, remember we have to go back and take that out. So we get x to the 1/3 equals 2, and x to the 1/3 equals negative 1. How do I solve those two equations to get my final two answers?
Wouldn't you just like cube both sides?
Correct. If you want to get rid of a 1/3 exponent, you can raise it to the third power. Oop. So x equals 8, and then negative 1 to the third is negative 1. So 8 and negative 1 are your answers. Any questions on that one?
Wait, can you explain what you did after you found the y values or whatever?
I switched back out the y. So you mean after the y equals 2 and y equals negative 1?
Yeah.
So we have to switch back to our original variable. So we basically reverse the substitution. So the first thing we did was we changed x to the 1/3 to y. Now we got to go back and change y back to the x to the 1/3. Any other questions? Okay. All right, will somebody read me the equations for number 3? Y equals
x squared minus 3x plus c.
and the other one?
Y equals k minus x squared.
And it was 212, right?
Negative 212.
Good, thank you. Okay, so first directions were to solve for c and k. I will always give you the hint of if they tell you to do like 2 or 3 things in a problem, always do the first one first. So whatever they said to do first, do that first. So that tells me in this problem I'm going to find the values of c and k before I do anything else. Any ideas how to find C and K?
You plug in -212.
Yeah, just plug in the coordinate into y and x and then solve for your C and K. So we get 12 is equal to -2 squared minus 3 times -2 plus C. So 12 is equal to 10 plus C, so C equals 2. And then 12 equals K minus, so plus 2 minus -2 squared. This part here at the end, on the second one, be very careful with that minus -2 squared part. You have to put that -2 in parentheses if you're not careful, if you're not watching everything and paying attention. So it will become 4 first, do squared first, and then minus. So it will be 12 is equal to K plus 2 minus 4. That's a terrible K. So you get 12 equals K minus 2, so K equals 14. Any questions on that part? Okay. For part 3, obviously on our test, I let you use your graphing calculator. I don't know if that helped some of you, but it should have, because you could do the work on the calculator and look at it, figure out where the points meet, and then do the work to back that up, because remember I told you had to show all work. You could use the graphing calculator capabilities, but it would have at least given you the answer. But how do I find the other point where they intersect? By hand, not on the graphing
You set them
calculator.
equal to each other.
Equal to each other?
Careful. When you say that, you have to understand that you're not setting them equal to each other. When you do that, because I can't set an equation equal to an equation. What you're really meaning is I set the right-hand sides equal to each other. I know it's semantics, but we've got to be careful when we explain things. So because they're both equal to y, we can take the right-hand sides and set them equal to each other. What you're really doing is substitution. I'm subbing out one of the y's for one of my x sides. So it's just got to be careful with what you say, because if you are required to explain, setting them equal to each other would not be a correct answer. So 14 minus x squared. So I'll take the right-hand expressions and set those equal to each other, solve. That should be pretty easy for you guys. Get everything to one side like we just did. So 2x squared minus 2x minus 12 equals 0. Divide everything by 2 equals 0, and you get x minus 3, x plus 2. So x equals 3 and -2. Well, we already got the -2 one, so that's a good sign. If we did not get -2, we did something wrong. So we've got that. We just need the other one. I think it does ask for the coordinate. Find the other point. So I need the y value as well. So just plug it into whichever one. I'll plug it into the first one because I like that one better. So 9 minus 9 is 0 plus 2. So 3. 2 is your other point. Any questions on that one?
Nah.
Wait,
What?
why is 0.32? Oh, did you plug it back in?
I plugged it back in. Yeah.
Okay, I just didn't see the work for it, and it looked like you got it from the X's, so I was
Yeah.
confused.
Yeah. No, I just plugged into the first one. I mean, it's easy to plug in 3, so I didn't actually do that work.
Okay.
I assumed you guys could do that. All right. Any other questions? Okay, moving on to number 4. Number 4 was not pretty for a lot of you. Okay. There are 2 ways to approach number 4. One's
Hey,
easy and one is hard. Yes.
And if Bill's mic isn't working, do you know how to fix it?
I probably do, but not in the middle of class. I can help her afterwards.
Okay.
All right. So number 4, there's a couple ways, specifically 2 ways that I know of anyway to do this. There's an easy way and there's a hard way. A lot of you opted for the hard way in trying to, what was it, 9x squared, and trying to complete the square on the 9x squared part, plus 12x plus 7. So that would not be a great idea because you can't factor a 9 out. So if you want to factor the complete the square, remember your x squared has to be a 1 in front to complete the square, and then you could compensate and bring your 9 back in. Some of you did this almost correctly and did a very good job with it. It is a very ugly fractional thing, but it's not the easiest way to do it. Instead, if I know I want it to be in the form of ax plus b squared, or not equals, plus c, I think it was. All right, make sure I got that right. Yeah, so easiest way to do it would be to multiply out this right here. So you get a squared x squared plus 2a bx plus b squared plus c. At that point, I know these two things have to be equal, so we can equate our coefficients. So this is my x squared term, so I know that 9x squared equals a squared x squared. So a has to equal 3. And then I could do the same thing with our b. I think it does it tell, hold on, wait, before does this tell me that they are, nope, okay, so we gotta be careful. But I guess it can't be. Anyway. All right, so at that point we know 2ab equals 12, and then b squared plus c equals 7. So at that point you get that b equals 2, and then c equals, what was that, 4, 3. Does everybody see how I did that? Okay, so let's see who's paying attention. Somebody find my mistake.
What x did you plug in the first one?
I didn't plug in any x. You should have realized that the x squareds go away.
Oh.
So if you have 9x squared equals a squared x, then obviously 9 has to equal a squared. So
Okay.
then I got a equals 3.
Can you give me a hint?
Can I give you a hint?
Yeah.
I will give you guys a hint. It is the a value that I screwed up on purpose on.
The A.
Yeah,
Okay.
Oh, it's plus or minus 3.
there you go. You have 2 sets of answers.
Oh.
If a is negative or positive, I still get 9. And if both a and b are positive or negative, so I have 2 sets of answers. And that doesn't affect your c value still, because it's b squared, so that won't matter. But you have 2 answers, so it could be 3, 2, 3, or negative 3, negative 2, 3. Either answer does not affect your answer to part B. I don't know if they would have required both or not. You probably would have been fine on 3, 2, 3. However, I want you guys to all remember when you take the square root, you have to analyze the plus or minus case as well. But if you just would have used the top one, I would have gave you full credit, but you always want to think about that, what happens there. But that is by far the easier way to do it. If for some ungodly reason you want me to show you complete the square, I'll show it to you later, not during class time, because it's going to take a little bit of time. That's not useful. Multiplying this out and setting them equals a much easier case. Okay, so we're going to do
Wait,
that.
that works for every single one of them?
Not every single one, but if they say write this in this form, you can do that, yeah.
Okay.
Now, sometimes they'll tell you complete the square, and you'll have to complete the square. But this is a very nasty completing the square problem, so this is a much better method. So we get 3x plus 2 squared plus
Oh
3.
no, I did not get 2 on number 3.
When you plugged in 3?
Yeah.
3
Oh.
squared minus 9 plus 2 is 2.
Why do I have to plug in 3?
Because x value is 3.
But it could also be -2.
Then it's 12. And we were given that point, sweetie. So why would you don't want to use that point?
Okay.
Okay. So now for part B. You had to unfortunately use this answer for part B to be able to answer it correctly. So if you couldn't get A in this case, you were kind of screwed on B. In normal situations, however, again, I did let you guys have a graphing calculator. You could have looked at the graphing calculator, graphed it, and seen what exactly this was. So what we're doing and looking at is analyzing this function right here and asking ourselves, what values does that function take on? So in other words, in a fancy way, what are they asking for?
Range.
The range. They're asking for the range, the y values. So you want to look and see what happens when I take 1 and divide it by another number. Well, you want to ask yourself, what's the biggest and what's the smallest? Is there any gaps? So you ask yourself, is there anything I can't plug in for x? Is there any parts where that is undefined? In other words, well, it's a fraction, so what can I not have with a fraction? Where would I have any errors?
A 0 in the denominator.
So can 3x plus 2 squared plus 3 ever equal 0?
No.
Okay, someone besides Kayla, why not?
Yeah, but oh wait. You want me to say-
I want other people to think as well, sweetie. You are correct, and I'm assuming you have the correct reasoning, but I want someone else to try to figure out why.
What was the
If you
question?
square something, you can't get a negative.
And then what are we doing after that?
Adding by 3.
Right. So the smallest this could be, the 3x plus 2 squared, is 0. It could be 0, and when you square 0, you get 0. However, we are then adding 3. So the smallest the bottom could be is 3, or sorry, yeah, the smallest the bottom could be is 3. Like it can't get any smaller than 3. So it obviously can't ever be 0. However, it obviously can be bigger than 3. So the smallest value this is will be 3. The biggest value will be infinity. So in other words, we have a fraction that is somewhere in between 1 over 3 and 1 over infinity. So compare those values, 1 over 3 versus 1 over infinity. Which one's bigger?
Isn't it 1/3?
Yes, it's 1 over 3, because what's 1 over infinity?
It's close to 0, like really
It's
close to 0.
basically 0. So in other words, your function goes from 1/3 to 0. If you graphed your function, it would look something like that-ish, curved. Maybe, I don't really know because I didn't graph it, but it looks something like that. Because my biggest value, and it would be actually somewhere like over here, negative, but whatever. The biggest value is going to be 1/3, and then as x either moves to the left or to the right, the denominator gets bigger, so it's going to slope down to 0. So your range is 0, 1/3, parenthesis on 0 because it never actually reaches 0, and a bracket on 3 because it does actually reach, or 1/3 because it does actually reach 1/3. Does everybody see how I figured that out?
Yes.
Mm-hmm.
Okay. Analyzing functions is going to be something that is very helpful when you think about their graphs and things like that. So especially in a fractional form, you always want to think about what's the biggest value the bottom can be, in this case because it's a 1 on top. So I only have to analyze the bottom. So what's the biggest it could be, what's the smallest it could be, are there any places where I can't have a value, et cetera, et cetera. So part B there was a little tricky, but you also had your graphing calculators. All right. Moving on to number 5. It was x plus 1 is less than 12. Okay, some of you need a little bit of help with your inequalities. Okay. I don't remember how many, but I remember at least a few of you, and please, dear God, don't ever do this. Just said, oh, x is less than 12, x plus 1 is less than 12. Can someone tell me why I can't do that?
I don't know.
Because they're multiplying.
Correct, that's one reason. But think, so very easily you could give a counter example to say why that's false.
Equal to 0.
So it only works, as Deborah just mentioned, when it's equal to 0. Why does it work? If this 12 had been a 0, why am I allowed to do that? Can anybody tell me that?
I don't know.
It's because you can't.
But you said why?
And you said if it's equal to 0, you can do that. And you're
No,
wrong.
I didn't say if it was equal to 0. I said that was one of the reasons.
Well, you said if it was 0, basically if it was equal to 0. You can't do that if it's 0 either. That is a wrong statement.
If it was an equal sign and it said 0.
If it was equals, you could. But if you
Yeah,
change the
that's what I
12 to a
was
0,
saying.
you cannot do that on the board either. Can anybody tell me why you can't do that on the board?
Well, now you're missing a 12.
I changed them all to 0s.
Yeah, but you have to move it over.
I'm not there yet. I'm saying if it was that, why can I not do that?
I don't know.
If x is less than 0, what is x then?
A negative number?
Or
If-
negative integer.
Well, it could be a irrational number, so just a negative number. If x plus 1 is less than 0, that means x plus 1 then is...
X is less than negative 1.
But it is...
Less than 0?
But it is...
Negative.
Negative. There you go. What happens when I multiply two negatives?
You get a
They become
Positive.
Is a positive number less than 0?
No.
No.
No. You cannot do this either with inequalities. You have to be very careful. With inequalities, you need to do number lines. There's a reason we do these. So x plus 1. So we do need to move the 12 over and get it compared to 0. That is something we do. I'm going to go ahead and multiply this out. And then we will factor. So most of you that did this correctly. So plus 4 minus 3. However, at that point, you just said x plus 4 is less than 0, x minus 3 is less than 0 for the most part. And that is not a true statement. So instead, anytime you're using a more complicated function, such as a quadratic and things like that, and you want to compare it, you want to do your number line analysis on both of them, just like it was a derivative. So obviously this will be negative 4, and that'll be 3. It'll be negative, positive, negative, positive. Negative. Since we are multiplying them, and we want the outcome to be less than 0, what do we know about both quantities? What do they need to be? If you're multiplying two things, you want the answer to be less than 0, what do they gotta be?
I don't
One
know.
has to be negative.
And?
The other
Positive.
positive.
So you need one to be negative, one to be positive. That only happens in the middle area here. So they have to be opposite signs, was the word I was looking for, or generally is what I was looking for. So if you're multiplying two things, you need them to be opposite signs in order for them to be negative as an outcome. So
Wait, how did you find those signs?
what makes x plus 4 0?
Negative 4.
And then what makes x plus 3 or x minus 3 0?
What?
What makes x minus 3 equal to 0?
3.
Okay, so that's the numbers that go on my number line. If I go to the right of negative 4, x plus 4 will be positive. If I go to the left of negative 4, x plus 4 will be negative. And then I did the same thing on the x minus 3. It's just like a derivative analysis.
I can't do any derivative analysis.
You can put numbers on a number line.
Yeah, but then I don't know what to do with them.
Plug them in to see if they're positive or negative. Numbers to the right,
But I
numbers
don't
to the
know
left.
numbers.
You pick a number to the right of negative 4. Any number you want. You pick your favorite number to the right. Then pick your favorite number to the left. Plug it in and see what you get.
Oh my god, I'm gonna kill him.
Okay. So your answer here would have been from negative 4 to 3. It is not equal to 0, so it's a parenthesis on both. And no, that's not an ordered pair, that's a interval. Okay, so anytime you come across a complicated inequality, you want to do a number line analysis just like we do with our derivatives. Okay, any other questions on that one? Okay. Number 6 shouldn't have been too bad, at least for finding the points of intersection. So y is equal to x cubed, and then what was it? X
plus 1 times x squared plus 4.
Here we go. Okay. So if we want another point of intersection, just like we've already done, we are going to substitute and set the right-hand sides equal to each other. I'm going to go ahead and multiply out this one, so you get x cubed plus x squared plus 4x plus 4. On the outset, you're thinking, how do I solve a cubic? But what we should realize is that the cubic terms are actually going to cancel out.
Cat.
And then you can factor that, and you get x plus 2 squared. So x is equal to negative 2. And did they ask for the coordinates or just where? Okay, so you can find that point just to be on the safe side because it's kind of a little ambiguous. I would plug it in to the first one because it's much easier, obviously. So you get that y is equal to what, negative 8, so negative 2. Negative 8, just to kind of show, just in case they're looking for that y value, because it doesn't really explicitly say. And then the second part should have been super easy for you guys. Just use differentiation to find the gradient. Remember we talked about gradients, the slope. So basically just find both your y prime values. So y prime is equal to 3x squared. For this one, you've already multiplied it out. So that derivative of this is much easier than the derivative of this. And I don't think they can fault you for that. So y prime for this one is 3x squared plus 2x plus 4. They can't, I don't think they could make you take the product rule, but you could have done the product rule if you really wanted to, and you would still end up with the same answer. And then just plug in negative 2. So y prime is equal to 12 here, and y prime is equal to 12 minus 4 plus 4, so 12. I feel like when I did it before they got different answers, but I don't know. Oh, yeah, no, that's right. Okay. So, there. Any questions there?
I don't know.
Okay. All right, moving on to number 7. Some of you made a very bad assumption here in that x and y had to be integers. X and Y do not have to be integers. Some of you just started trying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah, that was me.
That gets 0. That got you 0 credit. Like that was just a big X. Like nope.
That's funny.
I'm gonna hope. Like I honestly kind of hoped everybody just knew the answer off the top of their head.
Wait. You told me that when I asked you that X and Y were both 5.
They are.
Oh, so I got it right.
But that's what I did. I just like.
You have to show some work. You
I
can't
all
just.
They can both be as 5. So.
Yeah. You can't just say 5 and 5. It's done. You should know the answer off the top of your head. Yes. But you should not just be like, oh, 5 and 5. Clearly, you're going to have to show some work.
I didn't do that.
And the other, like I said, the assumption that most of you made was that they had to be integers. They do not have to be integers. For instance, if it was x plus y equals 11, they would not have been integers. So you have to be careful with that. And you do need to show some work, not just be like, hey, here's the answer. So you do need to do a little bit. This is calculus. Like this is straight up calculus. This is our maximization and minimization problems where you're trying to solve for a max or a min. So relatively easily speaking, you're just going to solve for one, plug into the other one, and then find the max or min using calculus. Or you could have done it in algebra method, but I'll show you this in a second. So you got x plus y squared, and you know x plus y equals 10. Easiest one to solve for is solve this one. I would solve for y. So y is equal to negative x plus 10. Plug that in, so you get x squared plus negative x plus 10 squared. So that's x squared minus 20x plus 100. So you get 2x squared minus 20x plus 100. If you were to try to find the max or min of this, you could either do one of two things. You can take a derivative and find its max or min, or you could do algebra 2 and find the vertex of this parabola, because this is a parabola. So basically you look at the function, and I'm going to call it a different variable just so we don't get confused. So z is equal to 2x squared minus 20x plus 100. If you graph this or talk about this, so z prime is how I would do it because it's easier. 4x minus 20, set it equal to 0, which is how we've done everything. So you get x is equal to 5. So that is the work that we were looking for. Again, alternatively, if you didn't want to use calculus, which is so why they can ask this question, because they don't require a ton of calculus, you could find the vertex of that if you wanted to. Oh, shut up there. But yes, in case anybody doesn't know, if you're trying to find like a least value like that, you basically just find the middle value if it's a basic one like that, because you're making the squares as small as possible. Okay, 8. Should have just really easily used one of the formulas, which I don't have in front of me. Somebody's knocking stuff over.
No.
So you can do a sub n is equal to a sub 1 plus n minus 1d. There's that one. I think that's the one we have to use.
Wait.
Yeah, that's what we use. What?
I'm looking at the other one.
Okay, we're on number 8.
Yeah,
so,
I know. I'm working slowly behind you.
Okay. So you should realize that this is an arithmetic sequence, not a geometric sequence, because it's incrementing by 0.1 each time. It's not multiplying. So we're looking for we're looking for n. So if we have this formula, we have to have all the other terms. So we need a sub n, a sub 1, and d. A sub n, in this case, since we're looking at how many terms are in the sequence, we're going to make a sub n the very last number. So that's 100 in this case. So we can use that formula and say, oh, we know 100 is equal to the first term, which was 1, wasn't it? Yeah, 1.0 or just 1. plus n minus 1 times 0.1. I need to go buy some more markers today. And then just solve for n. So anytime you get these arithmetic or geometric questions, if you get one, usually you're going to use a formula somehow. So you get what? 99. I can subtract the, I won't do that. Equals 0.1 n minus 0.1. So you get 99.1 is equal to 0.1 n divided by 0.1. And n equals, I don't know what that is off the top of my head. But yes, I do. I'm done. 991. Everybody see how I did that, hopefully? Not confused by anything, hopefully. Asking questions if we need to, so I don't yell at you again today.
Okay, look at it. I'm behind.
I know you're behind.
Yeah, not gonna lie, it looks like .ln, but I know it's .1 n.
Yes, there's no such thing as point ln. So
I
yes.
know.
But yes, I do see how you see point ln. Anybody else have any questions about?
Well, where did you get all those numbers from?
The problem? If I'm looking for how many numbers, I'm going to use a sub n to be the last term. So that's 100. So anytime you're trying to figure out how many numbers are in the sequence, you always use that last term. And even if you couldn't get part A, part B should have been really easy using the formula, which, let's see if I can remember it off the top of my head. So S sub n is 1/2 n
No, we don't
A plus
erase the
L?
bottom line. Okay.
It was too late. By the time you said that, I was gone like 4 seconds ago, sweetie.
Yeah, I know there's a big lag, but I didn't know you were erasing it until line.
I think that's the formula, isn't it? Can someone corroborate? Did anybody have their ACE formula sheet?
Not great.
Some
No.
formula. Yes,
I wasn't talking to you.
I know. I still said yes.
Kitties are climbing things, and they can't do that.
Yeah, that's the right formula. Okay, so you just use that formula. Like literally, they give it to you. So it's 1/2 991. A was 1, and L is 100. And you're done. Whatever half of 991 times 101 is. And I don't know off the top of my head, so whatever that answer is, you guys can plug that in the calculator.
Wait, is that E?
L
Oh.
for last.
Yeah, definitely. I thought it was a C. Oh my god.
Alright, and then number 9. So you're just using, so you needed the ratio in this case. So they have the first term. Given that the sum to infinity is 5, so again, we're going to use that summation formula. Once they give you information like that, you're usually going to have to use it in one of the equations. So we know the sum to infinity is 1 over 1 minus r, or no, a1, not 1. In this case, it's 1. So it's a1 over 1 minus r. We know we were given a1, so we know 1 over 1 minus r is equal to 5. Just solve that equation for r because you do need r for the second part. So you get 1 is equal to 5 minus r. R is equal to 4. That doesn't make sense. I did something wrong. Five minus 5r. There we go. I can multiply, guys, I promise. So 4/5. That's much better. Once you have r at that point, they want you to find the sum of the first n numbers that exceeds 4.9. So we go to our regular formula, which is a sub 1, 1 minus r to the n over 1 minus r. And we want the sum to exceed, so we want this to be bigger than, what was it, 4.9? Yeah, 4.9. So we say 4.9 is less than a sub 1, which is 1, 1 minus 4 to the n over 1 minus 4 fifths. God, I'm going crazy apparently this morning. So we get 4.9 is less than, we can drop the parentheses here. And 1 minus 4/5 is 1/5. Multiply both sides by the 1/5 to get rid of my fraction on the denominator. So you get 4.9 over 5 is less than 1 minus 4/5 to the n. Subtract the 1. You get, what, 0.1 over 5 is less than negative 4/5 to the n. I need to erase this up here. At that point, we need to get rid of this negative, so I'm going to have to multiply by -1 on both sides, which means I will need to flip my sign, so 0.1 over 5 is greater than 4/5 to the n. So now the question is, how do I get n? How do I solve for n?
Log.
That is correct. Good job, Miss Deborah. I'll use ln's instead of logs, but yes, we use logarithms to get exponents out. So take the ln of both sides, greater than n ln. By taking the log or the ln, remember you're allowed to move the exponent out front, so I went ahead and moved that exponent out front for us. And what would my next step be, somebody? Somebody? Anybody? What do I do next?
Divide by ln.
Careful. Divide by...
ln of 1/5.
No.
Okay,
ln
then
of
I
4/5. We're trying to get the n by itself. So we need to get rid of that ln of 4/5. I figured that out. So we get that. And this you put in your calculator, 0.105, because you would have a scientific calculator capable of doing this, is greater than n. And now we get to play a game of Find O'Donnell's Mistake again.
Me, I'm the mistake.
I hate this game.
You're not my mistake, Miguel. You're, so...
Dude, there's like a lot of work there.
There is a lot of work there. It's a very small mistake, and I'll give you a hint, it comes towards the end.
I would really hope so.
It does. I wasn't that mean.
Oh, you divided by a -1, you didn't flip the sign, right?
I did. From the bottom line at the right to the top line at the left, I switched the sign when I multiplied or divided by the -1.
Wait,
Oh,
but where'd the negative go?
Oh, you're right. Where did the negative go?
Boom. There's your mistake.
You made 2 mistakes.
Oh, it was... I did make 2 mistakes. You're right. Hold on.
Oh, damn it.
I didn't catch that. The bottom left one, or sorry, the bottom right one was also supposed to be negative because 4.9 over 5 minus 1 is negative 0.1. I skipped that step in my head because I was already multiplying by the negative 1 in my head. So that was good. You did find one mistake that I didn't mean to make. There is one more. This one's on
Another?
purpose. The second one is on purpose. The first one, that one I did not make on purpose. I
You didn't bring those numbers over to the other side.
What numbers over to the other side?
The negative ones.
Well, that's because I multiplied both sides by a negative. That's why I flipped the sign. So
Oh.
going from the bottom right, I multiplied both sides by negative 1 to get to the top left up there. So that's why the signs switched direction and the negatives went away.
Wait, hold on. Okay, I follow.
Okay.
It just took me a minute because I didn't know what was going on in the problem in the first place.
It's not good, but okay.
Well, I was trying to do the other math, and then you started doing this math, so I lost the other math, so I just got really confused.
Okay, I'll give you a bigger, more of a hint. It comes in the top left side somewhere.
You know?
Okay, I'll give you another hint. It's going from the second line to the third line. I don't know how much more I can give you.
Can you not divide by ln of 4/5?
You can divide by ln of 4/5.
Is it something with the signs?
Define something with the signs.
Like, is it like, are
The
they
signs of
flippers?
life.
Do you flip them or something?
Flip what? What signs? That's why I'm
Ah,
trying to figure. I'm trying to get exactly what you're saying. That's why I'm.
like if I don't know if this is a rule, so don't quote me on it. But like, if you divide by ln, would your signs flip? Or
No, that is not a rule.
okay, then I don't know.
ln of 4/5 is negative.
There you go, Michael. ln of
Why?
4/5 is negative.
Who just knows that?
Because you should know what ln of 1 is. What's ln of 1?
0.
0. You should also know what your graph of ln looks like. So your graph of
Yeah.
ln
Oh yeah, it goes.
does that, which you'll see in a second. So any number to the right of that 0, ln of that will be positive. Any number to the left of it before it hits its asymptote will be negative. You should generally know that ln of fractional numbers in between 0 and 1, or decimals, whatever you want to call them, any ln of any number in between 0 and 1, or log of numbers between 0 and 1, etc., they will be negative values. So this sign needs to be switched. So it is less than and is greater than. And then you've
Yeah, I never would guess that.
most of you would not, and most people would make that mistake. Because when you put this in your calculator on the left, you'll get a positive number, so you'll never know that you divided by a negative without paying attention, because what you're doing on the left is a negative on top and a negative on bottom. So the negative on top and divided by the negative on bottom will give you a positive number, so if you're not paying attention or knowing, like seeing that, you're not going to know to make that change. Okay. And it is 11, so you guys do number 10 for your homework?
I know how to do that one.
I'm hoping people do. Also, as a update, we should be getting access to math online books. So if you don't have your book and stuff like that, I gotta see what exactly it is. It's supposed to be like a whole little classroom thing where they have like assignments and stuff. I don't know. It's what Cambridge put out and we're using. So as soon as they actually give me access, I applied for it. But as soon as they give me access, I will get you guys set up in that. We'll start working on that as well. And we'll kind of weave AP Calculus in with AICE Math and kind of go back and forth on different topics.